Hi, I'm Mr. Tsevi, and today we'll be doing more problems on linear maps. Suppose that we are given the following map and then they're asking us to find out if it's linear. So they give us that R3 or R in 3 dimension, which maps all the way to 2 dimensions, whereby f equals to x, y, z, and then x plus 1 and y plus 2. So these three represent the vectors that we actually have in here. As you can see, we have 3 vectors in here. And then this one represents the 2 vectors that we have in here. As you can see, there are 2 vectors in here. So they're asking us to determine if this is linear. But we know this theorem that if f equals to 0, 0, then 0 equals to f 0, and then this one equals to 0. So then if this condition is satisfied, therefore we say the map is linear. We say that the map is linear according to this condition. So we can let x equals to y equals to z, which equals to 0. So my f in this case will be f 0, 0, 0. But what is my x? My x will be 0 plus 1. My y will also be 0 plus 2. As you can see, this will be 1 and 2. Therefore, this is not linear, non-linear. This map is non-linear because of it doesn't map the 0 vectors from 0 all the way to 0. So for it to be linear, we should be there was supposed to be 0 and 0, so that it shows that it maps 0 vector from 0 all the way to 0. So let's take another example, guys. Suppose we are given this problem. Let me just erase it all. Suppose that we are given this problem and they are saying that which one of the following maps T, L, I, F, which maps from 3 dimensions all the way to 3 dimensions. And then they gave us options. Option number 1 is A. They're saying I equals to x, y, z, which is equals to just x, y, z. So let's deal with this condition first. We can see that when x equals to 0 and y equals to 0 and then z equals to 0, therefore our I will be 0, 0, 0, which is equals to 0, 0, 0. So we can see that this I, it maps 0 vector from 0 all the way to 0. So this is linear map. So we can take a second condition. A second condition is B, which is F, X, Y, and Z, which is equals to 0, 0, 0, whereby this is x and y and z. So according to that condition, this means that x, even in this case, equals to y and equals to z, which is 0. So if that's the case, f will be 0, 0, 0, which is equals to 0, 0, 0. And then this is linear. This is linear map. Let's check a third condition, which is number C. Which is number C. Number C says that t, x, y, and z equals to 1, 0, 0. So this is x, y, and 0. So the condition of saying t equals to 0, whereby this is the same as this and this is the same as this, which is 0, is not met in this example because of why my x already it's 1 in here. So this is not a linear map. This is not a linear map. Let's check the last condition. The last condition says that, let me erase this one. The last condition says that L, X, Y, and Z, which is equals to 2x, not comma 3, 2x, not comma 3, Z, something like this. So if we can let, according to that condition, if we can let L0, which is the same as 0L0, which is the same as L00, this should give us 0. So if we can let x equals to y and equals to z, which is equals to 0, we can see that this is 0 and here is 0 and here is 0. So I can substitute where I see x, I can put 0. And then on this not comma 3, where I see z, this is z, guys, I can put 0. So which is the same as 0 and 0, which is L0 and 0. So this is linear map. So option number C was the only one which was not linear map. So you can see how easy these things are, guys. Let's take another example. So guys, let's take another example. Suppose that we are given f, which maps R into dimension all the way to 2 dimension, where we are given fxy, which is equal to x times y and y. So, but I told you that in order for something to be a linear map, it has to obey 2 conditions. The first condition is that we have to check for tx and y, which is tx plus tv, whereby we are going to consider x and y and x prime and y prime, which will be the element of R. So this is the first condition. You can use this condition to compute this. But this is the simplest condition, which is the second condition. And it says that AF x and y should be equals to F AX AY. So this is the condition that we are going to use. This is the condition that we are going to use. So I can just let x equals to y, and then I say they all equals to 0. But what is this scalar? This scalar I can just assign it to 3. I can just assign it to 3. So I'm going to take this part of the equation. So, but as we say that this part equals to that part. So, but what is my scalar? My scalar is 3 and f, which is 1 and 1. But this whole thing is equal to this one. Is equal to this scalar because of f1 and 1 equals to this part. So since f is multiplied by a scalar of 3, we must also multiply this side by a scalar of 3. And here it's 1 and 1 and 1. So this can be multiplied to be 3 and 3. We agree. But 3 and 3 is equals to f 1 and 1. This is our 3 and 3 equals to, multiplied by the scalar, like I said here. So, we can consider this part of the equation. This part of the equation. So, but my f, since the scalar is already multiplied, is going to be 3 and 3. So, my f will be 3 and 3, which is equals to this part, which is x multiplied by y and y. But what is my x? This is my x and this is my y. What is my x here? My x will be 3, and then my multiplied by my y, which is 3, and then my y is also 3 again. So this thing equals to 9 and 3, which is f 3 and 3. So, but we can see that 3f 1 and 1 is not equals to f 3 and 3. Why? Because 3 and 3 is not equals to 9 and 3. So this is how easy it is to proving this using a scalar. Let's take another example. Let's take another example. Suppose that we are given t where our t is x and y, which is equals to x squared and y. So they are saying we must check if this is a scalar. But I've already said that at of x and y should be equals to t of a x and ay. So we start with this part of the equation. So but at x and y is equals to a x squared and y. But I can just let x to be equals to y, which will be 1, and then a to be 2. So this is the same as 2t 1 1, which is the same as 2 1 1, which is just the same as 2 and 2. So since we calculated this is this part actually. So it will be 2t 2 and 2, which will be equals to this one. But this is x and that one is y. So here, since we're having 2, I can just put squared, and then here is just 2, which will be the same as 4 and 2. But we can see that 2t 1 and 1 is not equals to T2 and 2, which is not equals to, sorry, which is not equals to, which is 1 and 1 is not equals to, oh sorry, 2 and 2. 2 and 2, which is this one, is not equals to 4 and 2. And therefore, since this condition is not met, so it's not a linear map. Just like the first problem that we did with this type. Since it doesn't meet the condition number 2, therefore it cannot be a linear map. So thank you a lot, guys. This is the end of our session. If you enjoyed, please subscribe and hit the notification bell so that when I upload every time, you can be notified. And also, we are nearly to 100 subscribers. We thank you a lot. We thank you a lot, guys. Please also leave comments and then also hit the like button. And then also share our link to your mates, your respective mates. And also, you can follow me on part 3 of linear math.